Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at differentiation and the graph. So by the end of this lesson, you'll be able to solve problems involving the exponential function y equals e to the x. Alright, so let's look at question 1. Differentiate y equals e to the x minus x, and for what values of x is the curve stationary? So in order for us to do this, I'm just going to write y dash is equal to, what do we get when we differentiate e to the x? Well, we just get e to the x. And what do we get when we differentiate minus x? We get minus 1. Okay, so that's our gradient function. Y dash is equal to e to the x minus 1. For what value of x is the curve stationary? Well, the curve is stationary when the gradient is 0. Well, this is the gradient function. So, stationary when e to the x minus 1, the gradient, is equal to 0. So I'm now going to add 1 to both sides. E to the x is equal to 1. Whenever we want to find an unknown power, we need to take the log. So I'm going to do log base e of e to the x is equal to log base e of 1. I'm just going to take the natural log of both sides. And because we've got log base e of e, they cancel each other out, and I'm just left with x. Or we can bring this x down to the front because it's a power, and log base e of e is 1, so x times 1 is just x. Is equal to, well, log base e of 1 is 0. If I were to grab my calculator out and do ln, log base e is natural log, so ln of 1 is 0. So x is equal to 0. Okay. Let A be the point on the curve y equals 2e to the x, where x is equal to 1. Find the equation of the tangent to the curve at point A. So we've got our function y is equal to e to the x. What we want to do, in order to find the equation of the tangent, we need to know the gradient of that tangent. So I'm going to find the gradient function by differentiating. So I'm going to differentiate this. And when we differentiate this, I still get 2e to the x. Okay, when we differentiate e to the x, we just get e to the x. So technically we just have 2 lots of e to the x. So that's our gradient function. So when x is equal to 1, because that's what the question says, the gradient of the tangent will equal to 2e to the power of 1, which is just 2e. Okay. We also need to know what y is equal to. When x is equal to 1, y is equal to, well, we're going to use this equation here, 2e to the power of 1, which is just 2e as well. So technically the point, or point A, let's call this point A, is 1, 2e. Okay, that's 1, 2e. And it has a gradient of 2e. So we want to work out the equation of the tangent. Equation of tangent. We can use the point gradient formula, which is y minus y1 is equal to m bracket x minus x1. We have our x1, y1 here, and we have our gradient here. And we can just substitute those values into this formula. So we have y minus 2e is equal to m, which is 2e bracket x minus x1, which is 1. Let's expand these brackets. We have y minus 2e is equal to 2ex minus 2e. And then we can add 2e to both sides, so y is equal to 2ex. And that's the equation of the tangent at point A. Okay. Question B, show that the tangent at A passes through the origin. So if we've got this equation, y equals 2ex, we want to show that it passes through the origin. So y is equal to 2ex, origin is equal to 0, 0. So when when x is equal to 0, what is y equal to? Y is equal to 2e times 0, which is 0. And we can say, therefore, the tangent at A passes through the origin, 0, 0. Okay, question C. Find the equation of the normal at point A. Now we know that point A is 1, 2e. Okay, we've already established that before. But we need the gradient of the normal. And the normal is always perpendicular to the tangent. So if the gradient of the tangent, let's call that n capital T. If the gradient of the tangent is 2e, which we've established here, then the gradient of the normal has to be the negative reciprocal of it. So we flip it, 1 over 2e, and then we change the sign. So now we can find the equation of normal. So equation of normal at A, y minus y1 is equal to m bracket x minus x1. Here's our x1 and y1. So we have y minus 2e is equal to negative 1 over 2e bracket x minus 1. So what I'm going to do here is I'm going to expand the brackets. So you have 1 minus 2e is equal to negative x over 2e plus 1 over 2e. I'm going to add 2e to both sides over here. I'm going to add that to both sides to make it y is equal to negative x over 2e plus 1 over 2e plus 2e. Now I can tidy this up and make it one big fraction, which means I need a common denominator. This one says 2e, this one says 2e, but this one's over 1. So if I want to make it over 2e, I need to multiply the top by 2e as well. So y is equal to negative x plus 1 plus 2e times 2e is 4e squared, all over the common denominator of 2e. And that's it. That's the equation of the tangent, of the normal at point A. Question D. Find the point B where the normal crosses the x-axis. So we need the equation of our normal, which we said was y is equal to negative x plus 1 plus 4e squared all over 2e. And to see where it crosses the x-axis, that means we're finding the x-intercept, where y is equal to 0. So 0 is equal to negative x plus 1 plus 4e squared, all over 2e. Now, in order for a fraction to equal to 0, that means the numerator has to equal to 0. Or we can just multiply both sides by 2e. If we multiply both sides by 2e, we get 0 is equal to negative x plus 1 plus 4e squared. Well, we want to work out the point where b crosses the, where the normal crosses the x-axis. So we want to know what the x-intercept is. We want to know what x is equal to. So I'm just going to move that to the other side. So x is equal to 1 plus 4e squared. And that's it. So now that we've worked that out, we can say that therefore point B has to be 1 plus 4e squared, comma 0. Because it's an x-intercept where y is equal to 0. Okay, last question for today. Find the area of triangle AOB. So what this means is we'll probably need to graph this. so we can have a look and see what this actually looks like. Okay, so we want to graph y is equal to 2e to the 2x. That's our original function. That was our original curve. We also want to graph y is equal to, let's have a look at the equation of the tangent. Equation of the tangent is 2ex. We want to graph the equation of the normal, which is minus x plus 1 plus 4e squared all over 2e. And then we should be able to have enough to work out what triangle AOB looks like. So let's graph the first one, 2e to the 2x. Well, when x is 0, we've got 2e to the power 0, which is 2. Okay, so when x is 0, y is equal to 2e to the power 0. e to the power 0 is 1. 2 times 1 is 2. So let's call that 1, let's call that 2. It's going to go through here. And we said before when x is equal to 1, that y is equal to 2e to the power of 1, which is 2e. Now, what is 2e approximately equal to? That's about 5.4. So when x is 1, let's just say that's 2e. It's up here somewhere. Okay, so we know that the graph is going to look something like this. Okay, we know that the tangent at 1, 2e, let's do that in red, goes through the origin. So let's say it goes through there. That's our tangent. And then we need to graph our other one, our normal. Now our normal, we've already worked out that the x-intercept is 1 plus 4e squared. What is that about? 1 plus 4e squared. 30. Okay, so this is not going to be to scale at all. So I'm just going to call this 1 plus 4e squared, which is about 30. And that's normal. Goes through there. Now, this is not to scale. This should be a right angle if it was to scale. But here we've got our triangle. So we know that this is A. This point's A, and we know that this point is B. And now we should have everything we need to work out the area of this triangle, AOB. In order for us to do that, we need areas equal to half times base times height. So area of AOB is equal to half times base times height. Well, the base goes from 0 to 1 plus 4e squared. So the base is technically 1 plus 4e squared. And the height of this triangle is from 0 to 2e, so it's 2e. So we've got half times 2e is just e, bracket 1 plus 4e squared. I'm just going to write square units here. And let's expand the brackets to get e plus 4e cubed square units. Okay, so that's it for this lesson. Thank you.